joining us for Wildflowers and Insects with the Mass Audubon. The end of summer is very active with lots of wildflowers and insects about. From fields and fields' edges filled with milkweed, asters, and goldenrods to wetlands with carnivorous pitcher plants and cardinal flowers, each habitat has its own community of perennials and insects. So we're going to learn how these organisms interact and their importance in the ecosystems in which we live. And this is all led by Tia Pinney, who's a biologist, the lead naturalist, and an educator at Mass Audubon's Drumlin Farm Wildlife Sanctuary in Lincoln. Since 1994, when she first started working at the farm, Tia has overseen efforts to maintain New England's wildlife on their 206-acre property, managing staff and volunteers in planting projects and citizen science. I again want to thank the Friends of the Library for sponsoring. I want to thank the 175 folks or so who are watching live. And folks, just so you know, because she may not tell you, but I'm going to tell you, and hopefully she doesn't mind, Tia is getting over laryngitis, so she's not at 100%. She's playing hurt for us today. So folks, let's give Tia a big virtual round of applause. And Tia, you can take it away. Thanks so much.
Thank you, Robert. And anybody who hears my voice will know that the laryngitis is there. I may lose it completely for a second, but it always comes back. But I apologize for the frogginess. Not a lot we can do. Those grandchildren, taking care of grandchildren all last week. So there you go. The dangers of grandchildren. So today we are this is our roadmap. We're going to talk a little bit about seasonal energy. We're going to talk a little bit about pollination, and then we'll get into the flowers and insects of the season of this late summer time frame, and we'll talk a little bit about conservation at the very end. So off we go. Now, a little bit of science here at the beginning. I hate to do this to you, but you know, I just have to. I like people to understand where we are. So the thing about seasons is seasons are based on the availability of solar energy, and which is all about our orbit around the sun. Right. So here we are. We're approaching the September equinox when we will be at 12 hours of sunlight. And then we will continue on to the December the December solstice, when we will be down to about 9, back to 12 in March, and up to 15 plus. It's about 15 hours and 15 minutes at exactly Massachusetts latitude. If you're from somewhere else, you'll have to look that up for yourself. But you can see that we go from 9 to 15 over the course of 6 months. And that's a 6-hour difference. And so that is a gradual change that is happening constantly. That's the important thing to remember. It is constant. We focus on, solstice, equinox. However, for the natural world, there is a continuous shift and a continuous following of that change of solar energy. This is a cool graphic, but you know, the thing about it is that so in that solar energy, that dark blue, the dark blue line shows the difference between the summer solstice and the winter solstice, with 2 stops at the equinoxes. The pink line is the available energy in the system, and this is a hypothetical at this point, because this used to be very constant, but with climate change, the constancy is lost. We have the shift in seasonal lag, it's called, is all messed up. We had, look at this August, look at July, look at June, just think about these past seasons. Anecdotally, you've seen this, and we can project it. But what we have is this change in seasonal energy. And with climate change impacting the amount of energy available in the atmosphere, all of this is kind of a crapshoot at this point. But we will go forward and talk about what the organisms we have around us are, historically, where they are, what they're doing, and how they are likely to be impacted. So that's just my bit on energy and climate. And now we're going to move on to flowers and animals. Okay, so just remember, seasonal lag, seasonal change, all of it, seasonality, all of it based on seasonality is the premise of our ecosystem here. Seasonality is huge for us. It's huge for everybody. But there you go. So this is, when we talk about flowers, and we often talk about flowers and insects, but there are other organisms, but the vast majority are insects that are part of the animal pollination syndrome, the system. And so we have lots of different kinds of flowers, and this we will focus on flowers that are visually present this time of the year, August into September, and but they are the premise of all flowers. So all flowers are seeking out a relation, essentially. I shouldn't say all flowers. Most flowers are there to be pollinated. The presence of the flower, the shape of the flower, the way the flower is arranged, the nectar, the pollen, all of these things are there so that the insects and other animals can come and pollinate them and then ensure the next generation of the flower. For the animal, it's almost always accidental. The animal doesn't care about pollination. The animal cares about nectar and collecting pollen for their own food sources. And the fact that they pollinate a flower is inconsequential to them, but it's totally cool. So, and there are many different relationships, some of them very specific, some of them very general. Excuse me. And we will talk about those relationships. Here are examples of most of our more common animal pollinators. We've got butterflies, we've got beetles. The ladybug is a representative of the beetle group. We've got birds, probably the most critical around here, certainly, being our ruby-throated hummingbird. We have native bees. These are not honeybees, these are native bees, and native bees are absolutely critical. Flies are another group. These two fly. Oh, I'm sorry. Let me put my laser pointer on here. I'm pointing with my cursor, which most of you probably aren't picking up. So this is a fly down here, and this is a bee up here in the top right is a bee, and down here is a fly. They may look very similar, but you can learn to differentiate them pretty quickly. If you pay any attention to what's buzzing around your flowers. Notice the eyes on this in particular. The eyes on a fly are like gigantic, massive things that take up their head, and they also have virtually no antennae. Most of them. Bees usually have an antennae that are relatively long and usually have an elbow. They have an angle to them. And then over here down in the bottom right, we have ants. So these are all significant animal pollinators. And before we get into the sort of basic flowers of this season and the basic pollinators, we're going to talk about some special examples, which of relationships between plants and animals, which are our local carnivorous plants. This is the season for our local carnivorous plants. They come out they are highly visible in the fall. If you happen to live near a bog or a fen or any wetland that has pitcher plants, the pitcher plant flower is very distinctive. And once you see it, it's very recognizable. It's good sized, easy to find once you can pick it out. These are the pitchers themselves, and this is the pitcher plant flower up here. And then, but we only have one species of pitcher plant. There are many, but up here we only have one. And then we have sundews. We have a number of species of sundews around. Sundews are small and relatively a lot harder to find. And so you have to pay attention to sundews. But again, they will be found in wetlands. They have unique relationships, as I said, with insects, in which the pitcher plant is designed to hold water. The pitcher of the pitcher plant holds water, and in that water there are microbes and other things that will essentially digest the insect. When the insect falls in the water, some insect comes by. The pitcher plant has scents and stuff. The insect comes by. The pitcher plant, the insect falls into the water, drowns. The microbes in the water digest the insect, and the pitcher plant absorbs those nutrients. So crazy, right? It's such a fascinating relationship that it's hard to wrap your mind around it. The sundews, same concept, but different, um, different construct, which is that they have these leaves, which you may have, if you've seen them, they have leaves with little that can trap a creature. So here's this. This looks like looks like we've got a butterfly that has been partially trapped by the leaf of this sundew back here. So the sundew, when the insect hits these sensitive um, tentacles around the leaf, the the leaf snaps shut. The organism struggles, the more the insect struggles, the stickier the leaves get. They exude this stickiness and they hold on to the leaf, and then the sundew essentially releases enzymes that will digest the insect that they've trapped, and they will then absorb the nutrients from that insect. So this is how sundews and pitcher plants get by living in nutrient poor environments, um, and do quite well for themselves. Actually, sundews have been found to have the highest concentration of vitamin C in the leaves of sundew of any known plant, which is a fascinating little factoid. But you can see the sundew also has its own little flower. They still have to make seeds, but they're about using insects as a food source more as much as using insects as pollinators. So fascinating topic. But on we go. On we go to things that most of us can see the minute we walk out of our houses. Anywhere around us this time of year, there are two sets of flowers, which if you know anything about late summer flowers, most of you have heard about these before. And the first group we'll talk about are asters. Asters asters are part of the Asteraceae family. Sorry for the vocabulary if you're not familiar with it. Asteraceae is a family of flowers. Greek, they're named the Greek word for star, and aster comes from the Greek word for star, and you can see that when you look at these, they look like exploding stars. Other common names would be starworts and frost flowers. I've read for years. I read novels and novels, especially British novels and other novels. You'll hear frost flowers, and those are asters. So just if you didn't know that, there you go. But this is a huge family. Asteraceae is enormous. There's probably as many members of the Asteraceae family as orchids. They're right up there. Both of them are right up there at the top in terms of number of species. About 32,000 species of asters around the world. Asteraceae, I should say, not asters. I keep misusing the terms myself. So, but black-eyed Susans, blazing stars, ironweed, coneflowers, sunflowers, daisies, zinnias. There's just tons of different groups of flowers that all belong in the Asteraceae family. There are several genera, which I may use more than once. Genera is the plural for genus. So when we're talking taxonomically and we get more specific, genus, like we are Homo sapiens, our genus is Homo. And so, but there are several genera that have the common name aster. They used to all be in one genus, and then they had to split them up, make it more difficult for us to remember them, but that's okay. Here we have some kind of a sulfur up here and a monarch down here, and you can see that it's hard to see. Here's the proboscis of the sulfur into the flowers of the aster, and here again. We can't see the proboscis here. That's an antenna. But what's going on here is that we have a ton of tiny little flowers in the center and a whole bunch of flower rays that stick out to make a platform. So and this is important. We'll look at the next slide. Here we have a common eastern bumblebee, and you can see in the center are all the flowers, and there's probably, I don't know, maybe 20 or more in the center of this aster. This may be a wood aster. We have different kinds. This is a New England aster, the blue one. And then we have several different kinds of small sort of woodland edge asters. There's white wood asters, there's blue wood asters. we're not going to worry too much about the specifics here because we'll get lost in the weeds, and we'll never get to the end of the slide, the deck. So the thing to notice in this picture is notice the center of this flower is yellow, and the center of this flower is sort of a deep, kind of a deep purpley brown. And this is an amazing relationship moment here in that once the flowers of the aster have been pollinated, they turn color, they change color. And this essentially lets the pollinator know that this plant, this flower, sorry, is not a good nectar source anymore. It's already been pollinated. The aster is not putting the nectar is gone, the nectar has been drunk. Don't bother. Ignore this flower. Go to this one over here. This one is still good. This one still is a good food source for the pollinator. This one is no longer a good food source for the pollinator. And the aster is actually communicating with the pollinators to let them know that. At least that's one theory. It's a theory that I like. Nobody's ever proved why the asters change color. If in fact changing color is because it's communicating with the with its insect pollinators, but I just like that part of the story, so I buy into that one. Usually I ask for a little more data, but I like this one, so I let it go. Let go of the data. But you can see here are the mouth parts of this bee right here, that dark line, and it's about to stick its proboscis, its mouth parts into one of these tiny little flowers. The advantage of things like asters and these composites, if you think about any of the composites that we know, these are all composite flowers, they're called, is that there are so many little flowers there that they will keep producing for weeks. They will provide a nectar pollen source for weeks, and that's a critical piece as we come to the end of the season. Asters can vary from very short, a foot, up to 5 feet tall. Some New England asters can be very tall. Okay, now onto the real showboats of the season. The stars of the late summer flowering perennials around here are goldenrods. And goldenrods, there are, I don't know how many species of goldenrods we have locally. Quite a few, maybe 30, something like that. I do not try to differentiate goldenrod species myself. Some are pretty easy to pick out, and some are not. Some are hard to differentiate one from the other. But they definitely, you can, if you start looking at them, you will see they have different clusters. You can see that they belong to the aster family. They have these clusters of of tiny little flowers surrounded by rays. So they are a composite flower in that same way. They are good for all kinds of insects to utilize as a food source. They create these wonderful platforms for landing on or climbing on. They are considered a keystone species essentially. There are hundreds of butterflies and that utilize utilize goldenrods as a host plant for their caterpillars. There are at least 42 native specialist bee species that can only use goldenrods to eat from. Galls, if you look in the winter, once we've passed the flowering season, once we get into November and December and January, you can see various galls. You can see the growth galls in the summer where you get these weird bunching of leaves and things, and those are all galls, and that's an insect relationship, an insect or a mite or an arachnid of some kind. Has gotten in there and done its thing, but it's in relationship with the goldenrod. The goldenrod galls that you see in the winter, that the birds sometimes break into for food. There's the relationship of goldenrods in our local ecosystem cannot be overemphasized. Asters also important, but when you come to sort of the keystone flowering species of the late season, it's goldenrods. Here this is a predatory stink bug. These are, we won't go into the details, but most stink bugs, most bugs in this group, most insects in this group are they suck plant sap, but this happens to be one that is carnivorous. and it's waiting on the goldenrod for the other insects that come to pollinate the goldenrod, and then it will catch and eat and digest one of those and suck it up. This is a locust borer beetle. If you pay any attention to goldenrods, if you go out to go and look at goldenrods, you will find locust borers. They are beautiful. They're big. They're probably an inch. So they're big for an insect, and they are quite beautiful and stunning. And they are not harmful at all in terms of human beings. We always react to big insects as, but don't just take a deep breath and keep observing. Now, this down here at the bottom, we have another common eastern bumblebee. And notice that her pollen is very orange. Her pollen pellets that she has on her back legs, you can see there's one on her left leg and one on her right leg. The right leg's easier to see. That is goldenrod pollen. It is very orange. It's very bright. There are times when you'll see, I mean, depending on your eyesight, but sometimes when you're looking out and you see a bumblebee fly by at this point in the year, all of a sudden you realize there's these bright orange spots on this bumblebee. Bumblebees in particular are easy to see those pollen sacs, those pollen pellets. But so that means she's been collecting pollen from goldenrods, those bright orange pellets. Now, one thing I want to say in terms of ecosystems and diversity and functionality is that this is a hugely important plant for us in our ecosystem. But goldenrods have been spread. They've been taken and planted in other parts of the world. And in Germany, goldenrod, Canada goldenrod in particular, one particular species, is considered an invasive species. So just think about that. Think about invasive species and why we have invasive species here, but our species, our important ecosystem members, move it to Germany, and it becomes an invasive species because it doesn't belong in that habitat relationship. We'll talk about relationships more at the end. Here's another beautiful goldenrod image, and again, an iconic insect for us, the monarch, which is about to start its migration to Mexico. Not this month, but next month, by the end of September. Usually, most of them are on their way. Generation of monarchs of adults that will hatch out within the next month or so, depending on the climate, the weather. They will fly all the way to Mexico. They will live for another 9 months, and in that process, they have to fly all the way to Mexico. Most of the monarchs around here in the summer live for approximately a month, but this group, this end of the season generation, they need fuel. They need a food source, and you will see them nectaring on the goldenrods because they are common, because they are accessible. All those things. They are just a hugely important resource for late season nectaring. And this is a picture that was taken in September of monarchs fueling up before they left. My guess is this crowd probably flew off the next day or the end of the day. They often fly at night. And so that's our the other thing is goldenrods and allergies, hay fever, all those things. Goldenrod is not the culprit here. It's ragweed. Ragweed is a wind pollinated flower. The pollen is very light. It flies through the air. Goldenrod is an insect pollinated flower. The pollen is heavy and sticky. Goldenrod pollen is designed to stick to the body, legs, whatever part of the insect it can get to, and be carried by that insect to another flower, another goldenrod, where that pollen then will stick to that flower, that other goldenrod flower, and hopefully be able to pollinate the ovary of that flower. So goldenrod pollen is not the one that's flying around in the air, giving everybody terrible seasonal allergies late in the season. It's the pollen on goldenrod doesn't float. So just there, little, because there are people who remove goldenrod from their environs because it's, but it just so happens that goldenrod and ragweed emerge at the same time. Another seasonal favorite, cardinal flower. I don't know how many of you, how most of you feel about the end of summer. For me, it's quite bittersweet. But cardinal flowers will bloom. Usually, they may start in early August. They may not bloom until mid to later August, depending on the particular weather pattern. But they are iconic within wet, um, wet, moist, sunny but not full sun habitats. Forest edges, nice clean wetlands, areas where there's some water, but they're not completely inundated. And you will find cardinal flowers. They stand quite tall, um, and they are just beautiful. And the flower is fascinating, and it's totally designed to be pollinated by the ruby-throated hummingbird. It's hard to see, and it depends on how big your screen is. Over here, you can see these little pieces, these whitish looking parts that stick out over the top. Here are the flower petals on the bottom, and then we have these pieces that stick out over the top. And that's where the reproductive structures are, both the pollen and then the tube that carries the pollen down, that the pollen can grow down into the ovary. So both of those are up here at the top. And notice what happens so the nectar is all the way down at the bottom of the flower. You can see this bulge down here at the bottom of the flower. That's where the nectar is. So the ruby throat comes in, sticks her beak in there, and uses her tongue to drink up that nectar. And while she's doing that, the pollen, the pollen carrying parts of the flower are up on top of her head. So she is inadvertently collecting pollen, excuse me, and or depositing pollen at flower to flower. You can see it's like the flower built itself around the head of the hummingbird. I mean, other organisms can pollinate cardinal flowers, probably they must be. There's some bees that could possibly get in there and do some pollination, but you can see this is a really strong relationship between the shape of the cardinal flower and the head of the feeding hummingbird. So it's offering the hummingbird food, and in sorry, just lost a word. And then in response to that, the hummingbird's getting food, and the cardinal flower is getting pollinated. New York ironweed, another aster. You can see another composite aster. It looks similar to New England aster. It is not the same plant. It's very tall. It's fairly common. It's easily available in terms of native plants. When you go out to look for native perennials, you can usually find ironweed. It's an excellent perennial if you are in fact interested in planting native perennials in your yard, or in pots in your yard, or on your deck or whatever. It's a good plant, and it's quite lovely. It's beautiful. You can see in here, nectaring is a very worn. Look at how ragged it is. Some bird has been chewing on the edge of this. I'm sure it escaped several different interactions. My guess is this is a swallowtail. It's a Canada or an Eastern tiger. I don't know which one it is. It's in such bad shape and not a good view. But this is another important end of season or late season plant, I shouldn't say. And turtle heads. The native turtle head is white. There is a turtle head cultivar, or it's or a spontaneous mutation, also a spontaneous sport that's pink. And so there are quite a few pink ones out there nowadays, especially as people have planted them. But you can see this is an oddly shaped flower. It's supposed to, it's called turtle head because it looks like a turtle head. It needs a large pollinator to get into it. So this is one of the things. So here's a bumblebee down here, and here's a ruby-throated hummingbird. Something big that can force its way in through the mouth of the flower to get at the nectar, and then subsequently carry pollen from one flower to the other. One of the ways that organisms react, that the flowers and the insects interact, is specificity. Like that cardinal flower. That cardinal flower has created a system so that the ruby throat will have specificity going from flower to flower. When you're looking at the composites, the aster goldenrod type group, you're looking at generalists. They're picking up pollen from all kinds of flowers and they're depositing pollen on all kinds of flowers. And eventually it works out that they're carrying pollen from a New York ironweed to a New York ironweed. But one of the things that turtlehead has done and is not an is another common uh, system is that they the the organisms that can get into the turtle head ideally are going to another turtle head. Bees in particular will also often be loyal to a flower type while it's blooming. But at any rate, and so this big bumblebee that's getting into this turtle head, can go to another turtle head. It may stop someplace in between, but it is going to go to it it can't it's the only thing that can go from turtle head to turtle head, as opposed to other organisms that can go from spot to spot. Does that make sense? Sorry, I'm a little brain addled here this morning, so I'm not at my clearest. But there you go. Turtlehead. You can see from the turtlehead, it's in the same family as things like foxglove and snapdragons. Also plantains, believe it or not, but it's the plantain family. But you can see in that shape it's related to snapdragons and foxglove, which are not native, but that's okay. They're good plant. They're fine. They're fine to put into your annual display. Here we have Joe Pye weeds. Another group, Eupatoriums, Eutrichiums, depending on they've been renamed and taxonomically organized. But this is in front of my house. Some Joe Pye weeds and some bone sets. They're again all asters, closely related. And this is just one day I went out and I just with my phone I was snapping pictures of who was on these. Yesterday I didn't have my phone out with me, and I must have seen 5 different kinds of pollinators running around the bone set. And the Joe Pye that I have has come early. It's pretty much gone by now, which is early for this particular species in my yard. But at any rate, this is a flower fly or a syrphid fly, hover fly. They have a lot of different names, but it is a fly. You can see that the abdomen is different. The abdomen of a bee is rounder and almost always fuzzy, and this is smooth and flat. It's dorsoventrally, it's flat. So if you see it go by, that's the easiest way to pick out a flower fly is if it goes by you, you'll notice that the abdomen is not round at all. It's quite flattened dorsoventrally. And then down here is probably a sweat bee of some kind. I'm not sure what it's too. You can't see the head, you can't get enough, but I would venture this is some type of a sweat bee, which is another native bee. Now, the one thing I want to say is these two things are pretty tiny. Boneset flowers are not big at all. Boneset flowers are maybe 3/8 of an inch, half an inch across. So you can see neither of these is more than half an inch, maybe 3/4 of an inch if you really stretched it. But these are so you got to be looking. You got to be looking with sharp eyes. Just look for the movement, and then settle on a spot where they settle. If they keep coming, if they will come back to the same spot, or another will come to that spot because if they're coming there, it means there's nectar there. And so just watch the spot rather than try to trace one rapidly moving little critter. Watch a spot. Find a spot that they come to, and then focus on that spot and pick them up when they land there. That can be fun. And it's quite entertaining to see who comes and goes. But then let's see. Here's another Joe Pye with a big. This is a Canadian swallowtail, I'm pretty sure. But notice it's missing a tail. Again, this is the end of the season. You'll start to see, especially butterflies. The big butterflies. You'll start to notice that they're a little worn. They're getting to the end where there's not going to be another season of adults. They're moving into their overwintering prospects. Remember, they are very conscious of this lessening of sunlight and not in terms of the amount of energy available, but they are very aware. Both plants and insects are very, their sensory systems are picking up that change in the length of daylight and responding in ways that will allow them to be prepared for for the seasons to come. This is a season of transition. We are moving from high summer into fall and then winter, and they need to be ready because these adults these adults do not overwinter here. Only certain life stages can overwinter for most of our insects, and if those insects are not in the right life stage when winter hits, then they're in deep trouble. So that's the issue for most of our high summer insects is approaching the end of the season for them. We also have insects that are more of a late summer into fall um, lifestyle for adults, life cycle. The adults of these insects are more prominent late in the summer and through the early part of the fall until we get to a hard frost. And hard frosts for us have been getting later and later. Um, as a kid that grew up in Connecticut on a farm, hard frost you could almost guarantee you'd get one by mid-October. And now we're often well into November before we've seen a hard frost. We'll see, mild frosts, but a hard frost often doesn't and but it's erratic, so you can't depend on it. But these are katydids, and katydids are what we are hearing now. We hear cicadas through the summer. We don't have periodical cicadas, we have annual cicadas, but those are those high, that really irritating kind of noise. But what we're hearing now, if I'm working by my window in the evening, are wait a minute, I have to get rid of my laser pointer, and I have to hit that. Okay, hold on. We're gonna hear some. This is a true katydid. We are looking at angle winged katydids here. They look so much like a leaf. They are related to grasshoppers. They're in the same group as grasshoppers. However, they are much more leaf kind of looking. Here's the body. These are the wings up here. I'm sorry, I'm pointing with this. They have very long antennae. But now we're gonna listen to the classic tree katydid. This is it's maybe hundreds of them, all all singing in unison, and they're singing because this is their time for being adults and mating. And so we tend to get that wall of sound. What's behind that wall of sound? Here's a single katydid at a lower temperature. Because they're insects, they respond dramatically to temperature in terms of how fast they move and react and do things. You've all heard this one, I'm sure. You go for a walk in the evening this time of year as you go into September, and you will hear this. I love this sound. So that sound, multiply that by hundreds, and you get the first sound we heard that at a faster rate. Speed this one up and multiply it by hundreds, and you will get that wall of sound that we heard in the first one. Different katydids have slightly different sounds. So, but I was out, I completely forgot about katydids at one point. And one year I was out and I kept hearing this one, and I'm like, is that a tree frog? What is that? It was so slow and so distinct. And then I finally, after a little research, realized I was completely forgetting myself, and that it was a cool evening, and that it was a katydid. You will very rarely see the katydids that are making the sounds because they are way up in the tops of the trees. But here's a katydid on probably some kind of that might be a joe pie. Not sure, but you will find katydids. Just the ones that we were listening to are not the ones that you will see likely. The other big singer of the fall is our crickets. This is a field cricket, again related to grasshoppers. Grasshoppers have their peak, in the earlier in the summer. Katydids and crickets are more in the fall, although we do have spring crickets. But the fall crickets they The adults are mating now, and you can see that one of the big things, the difference between a cricket and a grasshopper is grasshoppers are taller relative to how wide they are. Crickets are flatter. They are wider than they are tall. Grasshoppers are taller than they are wide in terms of the shape of their body. Not all crickets are this dark, very classic looking, Jiminy Cricket character. Um, some of them are very pale and green, and you can hear them throughout the summer. The tree crickets in particular, we will hear during the summer. That but now in the fall, what we are hearing are the classic fall crickets. Supposed to be good luck to have one of these in your house. They too found cheerful. It's no wonder Disney picked a cricket to be a cheerful singing character. Um, Other sounds in the background there. Here's a different cricket. But there you go. Okay, wait a minute. I gotta stop all these now. Okay. So those are two sounds that if you listen as the sun goes down, as the evening comes, you will start to hear them. And you will notice them. And you can pick some of the sounds out if you've only got a few. But once you get that crowd of katydids all singing to each other, it is just an amazing wall of sound, and you will not be able to differentiate one. Oops, somebody's still talking here. Okay. Now let me go back to let me pick up my laser pointer again, and we'll keep going. I'm losing track of time here. Now, other insects that we see in the fall. This is a pond meadow, a cherry meadowhawk or a red face. I don't know, a white face meadowhawk. It's hard to tell them apart. But these are often late season dragonflies that we see. Again, strong relationship with flowers, mostly because not that they are pollinators, but that they are predators, and they come and use tall, narrow flowers, tall, narrow spikes as hunting perches. So if you see one, watch it and watch where it lands, and then watch what it does. They are fascinating to spend some time with, but they are an integral part of the insect food web, and we'll talk more about that. This is a handsome trig over here. It's called. This again it's a totally cool, and these pop up now August and September. They are all over the place. This is on some sort of a wild lettuce. Um, this one, they have this bright red head and thorax and a black abdomen and um, some great um, palps and antennae. Again, they're just everywhere this time of year. You'll also see spiders. I didn't put any spiders in this slideshow. I apologize to the spiders. But this is a time for, especially you start seeing jumping spiders everywhere um, in the end of the season, and it's all related to that concept of you know shortening daylight. I gotta get my act together here. I'm sorry, I'm anthropomorphizing, but I gotta get my act together. I gotta go out, find my mate. Make sure we get some eggs put together and set aside for the winter. Most of our insects and arachnids, the spider group, they overwinter as eggs, some as larvae and pupa. Eggs and pupa are probably or cocoons. That stage are more common than larvae, but they need to be in the right stage in the right place. They need to be in a place where they won't be exposed to extremes of temperature. Um, Depending on the species, those spaces differ. But this is the time when they've got to get that all happening um, in order to survive the winter. One of the oh, one of the issues of the climate change and the um, the randomness of our temperatures and our warm spells and our cold spells is that with that remember the seasonal lag wave that that what these organisms are depending on is that it will consistently get cooler. So if we suddenly get a warm spot when the organisms are based on getting consistently cooler, it can mess things up in terms of timing, and that often, and so we have to study that more. We have to learn more about that. We haven't been paying a whole lot of attention in terms of how that impacts the various organisms around us. But we have more and more data. Data is always nothing wrong with data is good. Um, I said earlier that we were going to talk about food web and relationships of organisms, and here we are. And so that we can't, we need to consider the big picture when we're remembering what's going on. The big picture is that we have we have producers. In this case, what we're talking about today, the producers are those late season perennials, those flowering plants that are out there bringing in all kinds of organisms that are using the nectar and the pollen for their purposes, but also supplying a food source for the predators of those animals. Here we have a bluebird, an eastern bluebird eating a fall field cricket, and here we have a large uh, a large hornet eating what I presume is a common eastern bumblebee. But those are critical parts of the system. Those are not good or bad. There's no judgment here. They are just things that happen. Sometimes they're introduced organisms. This is probably an introduced hornet, but still they have established in our relationships, and those relationships are critical. It's not up to us to decide which part is better than another. That's all that, I want to introduce that concept to you if you haven't thought about that before, that we can't manipulate the system. Once we start to manipulate the system, then we're going to screw it up. And so you think, I don't like spiders, I want to get rid of all the spiders, or I don't like hornets, I want to get rid of all the, I don't like bees, whatever it is. If you look at the system around you as it's functioning and think that way, then you're gonna make mistakes. You're gonna mess up your ecosystem, your local ecosystem. And when we all need to be aware of our local ecosystem, and by local I truly mean what's happening directly around you, not what's happening in the preserved, in the nature preserve forest, in the sanctuary that's down the road, or in the next town, but what's happening in your yard, wherever it is that you've got plants and things growing around you. So, oh, life cycles. I already talked about life cycles pretty much, but life cycles are critical. We have, especially for insects, they go through several different life cycles. They have eggs, they have larvae, caterpillars or nymphs, young, which are, look like the adults, but they're not reproductively powered yet. Um, and then we have adults, and then those adults will lay eggs. So all of that has to happen throughout the course of a year. Throughout the course of a season, you may have multiple generations in a season. You may have two generations in a season. You may have one generation in a season. It just depends on the species. But this time of year is when those life cycles and what's happening next are become critical in terms of how are they going to ensure that they are ready to get through winter, which is our defining season, in order to have enough population left to have those life cycles continue next year. And so that's why we need to understand life cycles. And that leads us into our conservation at home slide here, which is that how you go about um, impacting your habitats. So the one thing I would say, if you have an area that you can plant in, or that you are in control of, or even, if it's like, if there's some town property around you that you can use with people, but use mostly native plants. Plant mostly native plants, especially for these late seasons things. We need to plant throughout the season. We need plants that aren't just beautiful that flower in June and July. We need plants that are adapted to our habitats, that are adaptable to climate change, that can move, that can handle climate change, and that's mostly going to be our native plants, um, and that create food sources throughout the season as much as possible. So we need here's a this is a hooded owlet moth caterpillar, and It's on a goldenrod. Um, but we need, and to think in terms of creating habitat. And by that I mean, don't just think about what's beautiful. Think about how that beauty interacts with other things. It's totally cool to have some flowering annuals, even flowering non-native perennials, as long as you have native resources as well as, because and you can look for introduced species like zinnias and cosmos and things. Those are often very decent midsummer pollinator sources. But when we get to the end of the season, we really need to oh, what's that one? The succulent. Shoot, I've lost the name of it. There's a introduced succulent that's decent in the end of the season, but I've completely lost the name. But think think of how those beautiful things will be utilized, and think of relationships. Think of things that are happening as necessary, as critical, as beautiful in their own right. Most people look at this and go, "Oh, the poor bee," and I think, "Whoa, what a cool spider." I mean, you just have to appreciate how nature has evolved, and not try to determine what's better and not better, not put our not put our human judgment on it. Um, Tolerate mess. There needs to be some imperfection. There needs to be some messiness. Leave the leaves. We've got to stop using bark mulch. I know it's a paradigm shift for most of us. I was just having this conversation with my daughter-in-law the other day. She's like, "It's so messy." I said, I know, but it looks messy, but really think about what's going on here. You can have some tidy parts, but leave some mess. Oh, this is totally, when I was looking up leave the leaves, I was looking for a picture of I was online looking at an image of what that would look like, leave the leaves. And I came up, I, believe it or not, I found this on Amazon. Buy bags of leaf litter. It was like $20 for this bag of leaf litter. I don't know how big the bag is, but I was like, people are selling oak leaves as, as I was, so this is not what we want to do. We do not want to buy leaf litter. You do not need to buy leaf litter. You just need to leave the leaves that you have in your yard there. Just let them stay under the shrubbery. Just leave them there under the shrubbery. Don't touch them. You don't need to do anything to them. Don't take them away. They are critical for supporting all different kinds of life, and all different kinds of life cycle stages. Those leaves are one of the most critical parts of any habitat that you can help create. I mean, really, I can't stress anything more than that. And so what you want is this. You want this. Here we have fungi growing out of a dead log. Here we have a bunch of leaves. Here we have some moss, and we have somebody's pupa or cocoon. I don't even know what it is. That's going to that would have been covered. I'm sure the photographer uncovered it in the picture, but normally it would be covered by the leaf litter and protected by the leaf litter, and then it will pupate in the spring, and we will have some new organism. There's some lichens in here too. This is what you want. This is ideal. You need some areas like this in any space that you are in control of, or that you can influence. And here we have just a gorgeous picture. This is a dead leaf, and you can see that this is a monarch about to emerge. This is a monarch chrysalis that's about to open. And so there we go. I think I've come to the end of the slides. Yes, here we are. Questions. So we got in just under 60 minutes here, so we've got plenty of time for questions. This is, by the way, this is a spice bush caterpillar that is about to pupate. Usually they're green, but when they are ready to pupate, they stop eating and they turn yellow. And so this is a spice bush looking for a place to pupate, and was probably looking on a plant that with some leaves, because it likes to hang on a stem. And so but there you go. So we're on to questions, Robert.
So folks, let's give Tia a big virtual round of applause. And yes, let's take about 10 minutes of audience questions and comments. Madeline asks, would leaf litter purchased from wherever potentially transport harmful non-native pathogens, insects, and diseases?
Yes, thank you. Yes, thank you for that comment. That is absolutely true. Although most of them, if you're buying leaf litter, most of them will claim that they've been irradiated or something like that. But that just means it's killed whatever was beneficial in the leaf litter, anyways. But yes, transporting leaf litter is potentially transporting. It's like the same thing with bark mulch. You're potentially bringing in stuff that's not going to be beneficial to your system.
An anonymous attendee asks, is it okay to leave 2 to 4 inches of leaves on your garden?
Absolutely. Anything that's in there, any perennial that's in your garden, excuse me, it will in the spring you can look at it, you can check it, and people are like, oh, the perennials won't be able to get through, but in general they will get through. And if they need a little help, you can look at them. If they're all kind of curled over, then just give them a little touch, but don't take the leaves away. Absolutely, 2 to 4 inches, beautiful.
Robin says, wonderful presentation. Thanks so much. Nancy asks, do you rake the leaves off in the spring? And do you chop the leaves before leaving them? Do I need a special lawnmower?
No, you do not. I mean, you can chop the leaves on the lawn area itself. I also recommend reducing lawn area, but that's another question. No, the leaves that are under the shrubbery, leave them as they are. But if you chop them, you are in essence destroying any pupating insect. Not that this one would be in leaf litter, but if you chop up leaf the leaf mulch, if you chop up the leaves, you are chopping up um the pupa, the eggs, whatever's in there. You've probably eliminated them. So don't chop them and don't rake them away. Let them stay there. They will decompose into the ground and supply nutrients to your plants.
So actually, Bridget wants to know, what is that yellow insect in the last photo?
Yeah, this is a spice bush caterpillar about to pupate.
All right, Alicia had the same question and she says, thank you. Teresa asked a similar question. I think that probably has been covered. A different Teresa says, I have a 5-acre property of which 4.5 acres are natural. I have a plethora of goldenrods. Thank you for this presentation. Marcia says, the state is now spraying for mosquitoes to prevent triple E transmission. They say it's non-toxic, but killing food sources for birds and maybe killing other insects is affecting pollination, right?
Correct. Yeah, it's non-toxic to you, is what they're saying. It is not non-toxic. The trouble, this is a problem with Triple E and West Nile, and we have cases of them popping up around us. Is the spraying, and one of the disconnects is that there's no there's no data that shows a direct correlation between human cases, and spraying. It's there's no data that proves that spraying actually has an impact on the number of human cases. So that's a big gap. But also the spraying they're almost all the sprays are some sort of neurotoxin. So they are spraying to impact a certain life cycle stage of the mosquito. The mosquito is a fly. Mosquitoes are in the fly, the order of flies. And so whatever it will impact the mosquito, it will also impact a ton of other insects that might be at the same life stage. And so, yes, it definitely has an impact on our other species. So this is a huge issue of how do we protect the humans from these diseases that are becoming more prevalent, and how do we protect the ecosystems from overuse of pesticides? I don't have a solution for that one, to tell you the truth. But I do wish we could focus on the concept that the spraying is we don't have any data that shows the spraying is effective.
So someone with the initials AS asks, when you say cardinal flowers live in wet areas, are you talking about salt water or fresh water or both?
Thank you for that clarification, and I apologize for not specifying. They are freshwater. They are indicative of good, clean freshwater ecosystem if you have cardinal flowers.
An anonymous attendee asks, should ragweed be removed or is that beneficial to insects?
Ragweed. I think if you have ragweed around you and you have some allergy issues, then go ahead and take it out. It's not a question of it's not a question of it being particularly beneficial or not. Some ragweed species are introduced. Um, and I'm not sure of their basic range areas, but no, if you have ragweed around you and it's not something that is good for you, then go ahead and and pull it. That's the way I feel about it. It's not. I mean, I know we're supposed to let everything happen the way it happens, but ragweed is not something that the ecosystem will collapse if we take it away.
Ellen says great information and she hopes you feel better. Just in the interest of time, I'm going to combine these two questions and you can just give one long answer. Cheryl says, I saved my seeds for the local seed library, but I've noticed that my Joe Pye doesn't self-sow. Are you aware of any sterile Joe Pye varieties? And then Jean asks, can you deadhead Joe Pyle weed and ironweed to encourage rebloom?
Okay, so let's take the second part of that question first, because yes, you can cut them. You need to cut them earlier, much earlier in the season, if you want to encourage more blooms and and um, and encourage them to not be quite so tall, because both of those can get very tall. But my Joe Pye often fall over, but you need to cut them early in the season, like in June. Um, and so that yes, you can absolutely do that. Deadheading them at this point in the year, they will not, once they flower, I'm not sure how much more you'll get out of them if you deadhead them once the flower heads have formed. Now, the self-pollinating is probably true. I mean, maybe you don't have a large enough colony of Joe Pye, or it doesn't have there's not enough Joe Pye around it. Um, to transfer pollen to and from? That's an interesting question. I really don't have a clear thought on why your Joe Pye is not setting seed. Um, I would, that's a good question for Garden in the Woods people. If you are in Eastern Massachusetts, Garden in the Woods is an excellent botanical resource. Um, and even if you're not, but I wonder if they used to have a place where you could send them questions on their website. So Native Plant Trust. Native
Barbara
Plant Trust.
says, Barbara says, thanks for the excellent presentation. An anonymous attendee asks, maybe you just referenced it. Do you know of any resources where I can find or purchase wildflowers that are not sold at garden nurseries?
Yeah, and that's a very good point, because most garden nurseries will claim that they have native plants now. Most of them are cultivars. That's a whole nother question because they've been bred, but that not the cultivars are necessarily bad. But B, the big problem is that many of them have been pre-treated with prophylactic pesticides, especially the neonicotinoids. And so I would avoid buying perennials at places like, Home Depot or any of those, but look to your local nursery where you can talk to a human being who knows about the plants, and say, where have these plants come from? Can you guarantee that they have not been treated? And then the other, I mean, there are resources, but it just depends on where you are. There are a number of resources in Massachusetts, and you've just got to find one in order to lead you to others. There are several. There are some. I can name some here in Eastern Massachusetts, but I don't know that we have time for that. But the big thing is, go to a nursery. Don't go to like Home Depot or Lowe's or someplace like that. Go to a local nursery and say, I need plants that you can guarantee to me they haven't been treated. Um, and the more we ask for that as consumers, the more they will respond. Because if we don't ask, they'll just keep doing whatever they're doing. And Home Depot may tell you that they're not treated, and they don't know. They have no idea, because it's not the nurseries that raise them are not required to put that. They're not required to provide that information. That's the other thing. We need to get these pesticides that they're required to be listed, that this plant has been treated before it comes to market.
We'll take two more questions, or maybe three. Marcia says, is organic fertilizer safe for the environment?
Well, it depends. I mean, it depends on the trouble with saying something like organic fertilizer is that we that's a really broad term, and at this point um, the specification for organic has shifted because it went to a national. It's kind of a messy topic, organic fertilizer. But yes, you know, if you need to put if you need to fertilize, then look for compost. Look for, you know, look for some kind of, again, go to a place that you can talk to a human being who knows what they're talking about, and talk about what it is you think you need. I mean, I highly recommend a well composted, you know, material if you don't have enough leaf mulch to cover your area. You know, but so not a simple. It's a very gray space. I'm sorry. That's the thing. It's not an easy answer. But again, go find somebody who knows near you, who knows what they're talking about. Organic fertilizers can be great, or they can be who knows where they came from and what they really are.
So Bridget says, I used to live on North Street in Tewksbury. Now I live in Palm City, Florida. Bridget, that's what we call an upgrade. Okay, take me with you. Bridget says, I now have 5 acres, some pasture, some area around the house mowed. The rest is just growing. I want to let it become a wildflower meadow. Can you help or make any suggestions for a long-term transition?
Not, I'm afraid not in Florida. I really, I don't have any experience in Florida, but I encourage you talk to your conservation commission. Do you have a conservation commission in your town? Find a local nature sanctuary preserve. Um, you know, just look for organizations around you that are involved in habitat protection or any of those types of things, and talk to them, because I can't tell you what to do in Florida. I don't know anything about the way the ecosystem around you is working, is functioning, and how best to enable and help it. But good for you. I applaud your efforts. That's a lot of acreage to take care of, to
Uh, an
steward.
anonymous an anonymous attendee says, "Have hummingbirds started to migrate? Where do they go? I only saw one on my red trumpet vine a couple of times this past summer."
Yeah. Yeah, so they probably have started. They Our hummingbirds will go down to the Caribbean and Mexico. They Many of them cross the Gulf of Mexico. Just imagine that tiny little bird flying hundreds of miles across the Gulf of Mexico. But so when they leave is dependent on the weather conditions around them. So some years they'll leave quite early, and some years they'll leave later. But I saw one just the other day. I heard one fly by me actually at my house, and so um, they're probably still here, but maybe leaving any minute, kind of thing. But and yes, you know, year to year, it totally varies in terms of who's in your local neighborhood for the ruby throats.
So Jean says, if you want to see native town gardens, come to the Pepperell Town Hall Conservation Office, talk to them, and see the gardens within a 15-minute walk. There is a committee that has information and a plant guide on native and invasive plants. So that's the Pepperell Conservation Department. And my final question is going to go to Madeline. It might be unanswerable, but she really wants me to ask it. She said, I really enjoyed this presentation. I have an insect question that several of my friends at Spot Pond and the Middlesex Fells Reservation also have. About 3 weeks ago, we had several independent sightings of an unusual bright red-orange flying insect with clear wings with red-orange tint.
Sorry,
Don't worry
I don't know
about it.
why that started.
That's okay. That's probably our signal that it's time to wrap up.
A
So
bright red orange insect flew by.
yeah, so they were in small groups and also alone. I've never seen these in decades, shaped more like a fly or a bee, but larger. Definitely not a dragon or damselfly. What are they? Any ideas? And then she also notes the red orange insect had a glossy buckthorn, but oh, but did not seem to remain there. Oh, they were near a glossy buckthorn, but did not seem to remain there. The friend saw them near other flowers along the pond edges. A puzzle. Any ideas?
A puzzle. So red orange is a warning coloration. It means that they are probably growing on. Is there milkweed in the area? That's my first thought, because we have a number of red orange insects. We have milkweed beetles and we have milkweed bugs, and both of those would be red orange, and they might move back and forth to other flowers as well. But yeah, you're looking at warning coloration. You're looking at I might be poisonous, don't eat me, is why insects are that color. Unfortunately, without more detail, I can't get any further. I can't get any closer than that. But look up milkweed bugs and milkweed beetles.
A couple people in the chat think it might be a lanternfly, a spotted lanternfly, perhaps. So,
Oh, well, spotted lanternflies are very distinctive, and they have bright red spots on their wings, and they have been seen. But I don't. I mean, they're so distinctive looking that I wouldn't confuse them with a bee. They're sort of grayish wings, but with those bright red spots. And I believe there were some found in Middlesex Bell. So that's another interesting good thing to bring up. So check that out.
so Tia, we just hit 11:45 and we started a couple of minutes late, so we hit our mark here. Now I'm struggling with my voice. So folks, let's give Tia a big virtual round of applause for a great presentation. When you exit the Zoom, if you're watching live, you're going to get a feedback survey that pops up. Please take 60 seconds and fill that out. Let us know what you thought of today's program and what you'd like to see for future programs. I will email you all the recording as well as information about some other upcoming virtual programs before I leave at 9 o'clock. Okay. So Tia, any last words for the audience?
No, just pay attention. Pay attention. There's a fascinating world out there, and the more we pay attention, the more we can help take care of it.
Yeah, good words to end on. So thank you, Tia.
Robert.
In a few months, I hope everyone enjoys the rest of their day.